Following the introduction of modifications which had been indicated by the results of full-scale tunnel testing of the Avrocar at NASA Ames Research Center, a continuation test program was begun. The objective of this program was to prove the effectiveness of the new control system from hovering through transition in the presence of the ground up to free flight conditions. The program consisted in the main of further wind tunnel tests at Ames Research Center to prove the effects of these modifications, with a short flight test program at Avro to establish that the hovering capability had not deteriorated. A brief terrain test program was later added. The modifications provided for aft deployment of the peripheral jet sheet from the wing tip for transition and forward flight. Both vehicles were modified, one for further static and flight testing at the Avro facility, and the other for tests in the 40 by 80 foot tunnel at Ames Research Center. The changes were confined mostly to the wingtip, which was modified to divert the annular jet aft for increased forward thrust and improved aerodynamic and control characteristics. Transition doors, which extend around the sides and rear of the vehicle, act as flow splitters to divert the flow gradually from the annular hovering nozzle to the new wingtip nozzle for transition to forward flight. With the transition doors in the forward flight position, wingtip cascades at each side of the vehicle direct the jet flow aft. Pitch and roll control in forward flight is provided by the addition of 6 control vanes which operate in conjunction with the existing focusing control ring. On completion of the modification program, the vehicle was installed in the static test rig for functional checking of the new control system and to determine as far as possible that the vehicle performance in the ground cushion had not deteriorated as a result of the modifications. Lift, propulsive thrust, and rolling and pitching moments were measured during the 4-hour static test program. For rig testing, the control system was actuated by an external hydraulic system to be sure of maximum control movement. Tufting was used to provide a visual indication of control vane operation and jet flow. On completion of rig testing, the hovering behavior of the aircraft was checked in the tethers before commencing free flight. It should be understood that the original objective of the flight testing in this program was simply to determine that installation of the modifications had not resulted in deterioration of the vehicle performance achieved during previous tests. Early flights revealed that some deterioration in stability and control had in fact resulted from introduction of the modifications, and a number of flights were required to restore the vehicle performance in this respect. During this 6-hour flight test program, various minor experimental modifications were therefore made to the hovering control system and to the central jet configuration. The forward speed of the Avrocar, with the transition doors closed, was found to equal the speed previously achieved. Operation of the transition doors was attempted, but it was determined that the pneumatic boost available for the control system was not sufficient to overcome the large asymmetric load on the focusing control ring. A more powerful control actuation system is planned for future development. In its current configuration, the Avrocar was operating successfully in the ground cushion at a height of 3 feet and speeds up to 30 knots. Preliminary results from the new series of tests at Ames Research Center were also satisfactory. It was now desirable to extend the Avrocar's operation, and the program was extended to include flights over various types of unprepared terrain and natural obstacles. Initial tests over gravel and small surface irregularities presented no problems. We were now confident of the vehicle's ability to negotiate appreciable obstacles, and a rugged course, partially gravel and partially grass, with a 3-foot deep ditch, was selected for the next flights. Again, the Avrocar covered the course successfully, becoming, as far as we know, the first ground effect machine to negotiate obstacles of this nature. The vehicle had now clearly demonstrated its ability to operate over unprepared terrain, and landing pads were installed in place of the wheels for the following phase of testing, which included operation over soft ground. A number of flights were made over this course, which had a rough, eroded grass surface and a short 1-in-8 gradient. During most of these early tests, ingestion of low-density material presented some difficulty. The fuel control unit filters became blocked with small particles, causing the engines to be starved and resulting in flights of short duration. The problem was caused largely by dead grass and weeds. In an attempt to reduce the ingestion problem, screens were fitted to the engine inlets. No great improvement was achieved as the coarser material tended to block the inlets while fine particles still reached the fuel control filters. Introduction of additional filters resulted in some improvement, and it is anticipated that this handicap will be overcome with little difficulty during further development. In preparation for the final contractual demonstration, a representative course was selected where the vehicle could demonstrate its capability while remaining in view of the observers. The course was laid out to cover concrete, grass, and gravel surfaces and included 4 ditches. Precise directional maneuvers were necessary to avoid surface obstacles. Check flights over this course were performed as the next part of the terrain test program. Erosion due to jet impingement was not found to present a serious problem, and after numerous flights over the same course, only temporary grass browning occurred. In previous flights, the Avrocar had always flown directly over ditches encountered in the course. In order to prove that the ground cushion was not destroyed by sustained flight over depressions along which the jet may tend to travel, it was decided to hover the vehicle over the ditch and then fly out. Before the actual flight demonstration, the Avrocar was flown by a pilot from the United States Air Force Flight Test Center. Familiarization flights were first made over the concrete apron. Additional flights were then made over the demonstration course previously negotiated by Avro's test pilot. Despite unfavorable weather on the day of the flight demonstration, the Avrocar again displayed its ability to operate over terrain which had hitherto been beyond the capability of ground effect machines. In summary, the flight test program at Malton, concluding with this flight demonstration, was carried out concurrently with an extensive 54-hour test program on the second vehicle at Ames Research Center. The tunnel tests showed that if the known thrust losses were to be reclaimed, then the originally estimated performance was realistic. Also, that with the new transition control, transition from the ground cushion to in-flight was feasible. Throughout the entire Avrocar development program, vehicle performance has been compromised due to thrust deficiencies, and it is apparent that if height and speed are to be increased, an increase in thrust is essential. Studies already carried out indicate that a considerable thrust increase could be achieved by reducing turbine tip clearances and by redesign of the ducts, particularly in the region of the final nozzle. With a suitable thrust improvement program, it is believed that a static thrust in the order of the original estimate can be obtained, thus enabling the Avrocar to achieve vertical takeoff and free air transition to forward flight.